What's up, PCH? Today we're going to talk about solving polynomial inequalities. So far this unit we've specifically focused on solving polynomials, meaning, hey, I have a polynomial and it is set equal to 0 and solve for x. We notice in this example and in the rest of the examples on the notes, we don't have an equal sign anymore. We are dealing with an inequality. And while that is different, obviously, those are not the same thing, the thinking remains the same. What I mean by that, when we are solving a polynomial and we have it set equal to 0, that means we're looking for any numbers that we can plug in for x that will give us a y value that is equal to 0. And in what we know about any point that has a y value of 0 is that is an x-intercept. That's literally what we've been solving for like the last week or so, is x-intercepts from polynomials, solving for x. This inequality being here changes nothing for us, except for instead of solving for values of x that will give us x-intercepts, points that have y values that are equal to 0, we're looking for any number that we can plug in for x that'll give us some y value that in this case, for this first example, is less than 0. Which means, hey, where is my graph? Below the x-axis. That is all we are dealing with here. So we want to find all all x's that will give us y values that are less than 0. One really helpful way to do that is by having a visual, having a graph of my polynomial so I can look at it and say, hey, yes, I see that my graph's below the x-axis here. Those points are less, have a y value that are less than 0. Boom, I have my answer. And so you'll notice by looking at the steps for solving polynomial inequalities that I've included for you, step number 3, we're going to get to a spot where one option we have is to graph. And that's the option that I want to start with together. We will talk about the sign test second. That's going to actually be very, very fun. That's one reason why I love these types of problems, is because of the sign test. But let's go ahead and talk about graphing. I don't want to ignore steps 1 and 2. We will have to do this in other examples, but step number 1, get all terms on one side of your inequality so that you're comparing to 0. That's already happening here. I already have everything on the left side and then 0 on the right side. Step 1's done. Step number 2, factor. I already see that that's done. So we're good to go for step 3, graph this polynomial. Because we were graphing this during class together on Monday, I feel confident that we should be able to get this polynomial graphed already. And so I'm going to give you the time to do that. And then when you are finished or ready to check your work, press continue. All right, again, because we went over graphing already in a previous lesson, I'm not going to go through it right now, but we'll just highlight. In order to graph, I needed to find my x-intercepts, needed to determine my end behavior based on degree and leading coefficient, and then determine, hey, what is actually happening at each of my x-intercepts? Am I bouncing or am I crossing? Again, if you are not feeling the best about that, please reach out to me or look back at your notes so you can get in a good spot, because that's going to be a skill that's going to help us solve these polynomial inequalities. Okay, so let's actually talk about what we have here. We have my graph, and again, when I'm reading this problem, I have a polynomial and I'm trying to figure out where this polynomial is less than 0. Where does it produce points that have y values that are less than 0 or that are negative? And I can see that happening literally this entire time. Wow, having a visual, being able to graph a polynomial is actually very, very helpful. And so I can use this in order to help me come up with an interval. Interval notation, never going away. You're welcome. An interval, a range of values that will give us y values that are less than 0. And so naturally, when I'm trying to read what is happening on my graph, I notice from x values to -5 to 3, my graph is completely below the x-axis. But we come across this situation where, I've given you 2 different potential responses for answers that would answer this question. Are both of them right? Is only one right? If so, how do I know which one? And what I need you to think about is, hey, based on what my inequality is, the fact that it is x values that give me y's that are just less than 0, does that mean that my x-intercepts are included? Are my x-intercepts points that produce y values that are less than 0? Yes or no? I want you to tell me what you think. Yeah, hopefully you're able to think a little bit and like come to the conclusion that no, right? If my y value is 0, 0 is not less than 0. 0 is less than or equal to 0. But that's not what we have here, folks. We just want x values that produce y values that are less than 0, meaning we cannot include an x value of -5, an x value of 0, or an x value of 3 in my interval. And so if I'm looking at the second example, like, no, this is not true. Not every x value from -5 to 3 gives me a y value that's less than 0. At 0, that's not the case. It is not less than 0. And so I need to make sure that I am stopping at every single x-intercept here. And I'm not including 0, which means, hey, you'll notice I have parentheses around every single one of my x-intercepts. If I had, where's this polynomial less than or equal to 0, then yes, I'd be able to say, well, that is happening from -5, and that's included, because that's at a y value of 0, to 3, we are good to go. But that's not what we're dealing with here. We just want less than 0. And so this is my final interval. Excellent. Again, one thing that we can also do is the sign test. You can see that in step 3 here. You've never talked about the sign test before, and that's like one reason I love PCH is like really you're not going to talk about it as much until next year in AP Calc, but the more we're able to get started in thinking about some of these processes and some of these like thinking structures now to get us ready for AP Calc, next year's going to be so wonderful in so many ways. And so I want to make sure that in PCH, we are getting us thinking on some of those things. And so the second way that we can think about answering this question, hey, where is this polynomial less than 0, is by using a sign test. The cool thing about a sign test is that we're able to answer the same questions and make the same decisions based on different information or information that's being presented to us in a different way. Now, in order to do a sign test, the first thing we want to do is draw a number line. And on that number line, we want to make sure that we are including each of our zeros, each of our x-intercepts. And we know that we have them at -5, at 0, and at 3. When you're writing your number line, pay attention to the fact that I have spaced my x-intercepts out evenly. That's going to come into play. And that they're in order from smallest to biggest. I mean, we've been drawing number lines for a little bit now so far this year, so like that shouldn't be a surprise. And then, you know, if you wanted to, you could acknowledge that, hey, this arrow pointing to the left forever is going towards -infinity, and this one on the right is towards +infinity. Now, when we're talking about this number line, like, why are we focused on my x-intercepts in order to help us answer this question? Well, let's go ahead and take a look back at our graph. And something we need to recognize and think about is the fact that if I'm looking for like parts of my graph or places where my graph could go from being greater than 0 to less than 0, or the other way around, from less than 0 to greater than 0, the only spots where that will ever happen are where I have x-intercepts, right? Like if I'm looking at this piece of my graph from -5 to 0, I know that at an x value of -3, my graph is not going to all of a sudden switch from being below my x-axis to above it because there's not some like imaginary random x-intercept there that I don't know about. I know where my x-intercepts are. Like I know they're at -5, 0, and 3 based on like solving polynomials. And so that's why we're really only paying attention to these critical values, these critical points of my x-intercepts, because those are the only spots where I could have a potential change in whether or not this polynomial is greater than 0, like above my x-axis, or below it, or even equal to 0. And so that's why my number line is set up the way it is. And because of that thinking, the second thing I need to do is talk about test points. What I mean by that is if I'm looking at my number line, I see that I have this interval between -infinity and -5. And if I look back up at my graph, I know that any x value I plug in between -infinity and -5 is going to give me a y value that in this case, because I know what the graph looks like, is going to be positive, right? If I plug in an x value of -6, oh, it's going to put me at a positive y value up here. If I'm at -20, it's going to put me at a y value way up here somewhere. Like, I know based on the behavior of my graph that that is going to be true. Same thing if I'm looking, at some x value between 0 and 3. If I plug in an x value of 1, I know it's going to give me a y value that is negative. That is the sign test. It doesn't matter what x value you plug in between those critical points, between these intervals, because, again, based on what we know that it's not going to change. If I plug in a value of 0.001, so that would be like here, versus an x value of 2.999, both of those are going to give me negative y values and any x value in between there as well. And so, when you're talking about test points, I just need, hey, between -infinity and -5, what's a number? Let's go with -6. Doesn't matter what number, just matters that I pick one. Between -5 and 0, let's go with -1. Make it nice and easy. 0 and 3. Let's go with 1. Lastly, you tell me, what's a possible test point between an x value of 3 and an x value of infinity? Excellent. Literally anything. I'm just going to pick 4. One of the last things I want to do now is actually plug in that test point and see, hey, like when I plug in an x value of -6, do I end up getting a positive y value or a negative y value? Because again, like the actual number of the y value, like I don't really care what the number is. I just care, hey, is it positive? Is it greater than 0? Or is it less than 0? Because that's all that this question is asking me. Where is my polynomial less than 0? And so I went ahead and wrote my polynomial here for myself, just because I can't see it on my screen right now. And so all I need to do is think, hey, when I plug in -6 into this first factor, x squared, do I end up getting a negative number or a positive number? Well, -6 times -6 gives me positive 36. And again, I don't really care about the number. All I care about is the fact that it's going to be positive. Next factor, when I plug in -6 into x for x minus 3, -6 minus 3, I don't care what number it gives me. I just know and care about that it's going to give me a negative number. -6 minus 3, going to give me a negative number. Last factor, -6 plus 5, that will also give me a negative number. And so again, do I care about the actual y value, the actual number when I plug in -6? No. That's why your test point doesn't really matter, because you get different things. We only care about sign, hence why it's called a sign test. When I would multiply those numbers together, a positive times a negative times a negative, I would end up getting a negative times a negative, which ends up getting me a positive. And so, if I were to plug in any test point, any number between -infinity and -5 for x, it would give me a y value that is positive. Oh, we see that happening up here on my graph already. Like, that should not be a surprise to me. Wow, look at math being cool like that. Let's go ahead and try another one. When I plug in -1, -1 squared, that's going to get me a positive number, times -1 minus 3, that's going to give me a negative number, times one more factor, -1 plus 5, ooh, there's a change, that's going to give me a positive number. Positive times negative, so this here gives me a negative. Negative times a positive gives me a negative. Ooh, so for any x value between -5 and 0 that I plug in, I get negative y values. Whoa, that's no surprise to me here because that's what I see on my graph. Wow, math is cool. We love life. Yay. Dang, that's pretty cool. Okay, I'll trust you to try and plug in the next two test points and see, hey, do I end up getting positive y values or negative y values? My test point in this interval between 0 and 3, I end up getting negative y values, which again matches exactly what's happening on my graph up here. And then lastly, between 3 and infinity, plug in any number for x, and I will get positive y values. Now, we're in a spot where we've completed the sign test, because I know what my signs are between these different intervals. So now I can come up with my answer. Well, again, my polynomial here, I was looking for where this polynomial is less than 0, which means I'm focused on negative y values. negative y values, which are happening over these intervals, because it is just less than, no or equal to, that means my x-intercepts are not included. So if I'm drawing these on my number line, you can do this first, you can do it now, it doesn't matter, but open circles. And the intervals here are where I'm going to get negative y values. And folks, you have been reading number lines and creating intervals from them for weeks now. And so if I'm reading my number line, that looks like from -5 to 0, and from 0 to 3. That is where my polynomial is less than 0, and that is exactly what we got when we graphed as well, from -5 to 0 and 0 to 3. Either method works. We need to work with the sign test a lot, so we're going to be doing a lot of sign test practice, but we're also going to practice graphing as well. And so I have a couple more examples. I will give you the chance to go ahead and try this second example on your own, and then I'll show you my work to check it, and then we'll continue to practice in class tomorrow. But take a shot at this second example. Follow the steps, and I'd say try it with the sign test. Try it with the sign test. All right, here's your first check-in. Again, first step to solve a polynomial inequality, get everything on one side of your inequality so that you're like relating it back to 0. And so that's what I did in this first step. Then the next thing I need to do is factor, and that's the rest of what you see on the left side of my screen in blue, so that I could set up my sign test by putting my x-intercepts on my number line. Now you're ready to pick your test points and then to plug those test points in and complete your sign test. Right, regardless of what test points you picked, once you complete the sign test, it should look something like mine. Again, it looks like I'm kind of flipping back and forth between negative, positive, negative, positive. So how do we come up with our final answer? Well, we're looking for where this polynomial is greater than or equal to 0. And so I'm looking for plus signs, and then I incorporated the or equal to by having closed circles at my x-intercepts on my number line. And so when I am looking at these intervals, looks like I'm between -2 and 2, and then 5 and infinity. As an interval, that is from -2 to 2 included, so brackets on both of those, and from 5 to positive infinity. All right, team, there's one more example. If you want to try it, you can. If not, we'll go ahead and go over it in class tomorrow. Otherwise, we're going to do lots of practice. No need to feel like perfect on this stuff, but if you can internalize it and absorb it and do the best you can, you're going to be in a good spot for class tomorrow. All right, see you guys then.